Okay, FRQ6 for set number 7. Okay, so part A wants us to find the magnitude of the impulse of the force acting on the block. So we know impulse equals fat force times delta T. And so number 6 gives us this nice graph that we can use. So, okay, so from 1 to 2 seconds, there's no force. From 2 to 8, there's a force of 6. So we can, okay, so if impulse is force times time, we can find the area of this, and that'll give us the impulse. So we're going to break it up because there's 2 squares here. So 2, that's 2 to 8 is 6. So 6 times 6 is 36. And then that's 2 times 3, and that's 6. So then you just go ahead and add those. So you get 36 plus 6, and that equals 42. So the impulse is 42, and the units for that. Okay. Determine the block's speed at 1.5 seconds. So in the little blurb, it tells us that it has a constant speed of 5 seconds, and then at 2 seconds, a force is applied. So 1.5 is before 2, so the speed will remain 5 seconds because it's in the 2 seconds of the constant 5 meters per second. Okay. Part C wants us to determine the block speed at 6 seconds. So I'm going to go ahead and set up force. Okay, so at 6 seconds, that's right here. I'm going to go ahead and erase this so we have a clean graph. Okay, so 6 seconds is right there. So our force is 6. Mass is 4. So we can find an acceleration because at that time, force is constant. So that means we can find an A. Okay, so now that we have an A, we can just use our VF formula. Okay, so looking at time, so up until 2 seconds, it was 5 meters per second. And then the force got applied from 2 to 6 because we're looking at speed at 6. So that's going to be 4 seconds from 2 to 6. And then our VI was 5. So then you just do math. And get 11. Okay, now it wants us to calculate the net work done on the block between 2 and 8. Go and erase this again. So 2 and 8, okay? So we see that there's a constant force, so that makes it kind of easy on us. So work is equal to force delta x. In this time frame, there is a force of 6, but we need to find our delta x. So let's go ahead and so we need to set, okay, so let's go ahead and find our VF at 8 seconds. So again, we're just using that formula. And we already found acceleration during this segment right here when the force is 6. But now we have a different time. So now we're looking from 2 to 8, and so that's 6 seconds. And then plus 5 again. Okay, you get 14. So that's our speed at 8 seconds. Okay, so now with that, what we can do is common form. So delta x vf squared minus vi squared over 2a. Okay, so we have 14 squared minus 5 squared, because at 2 seconds it is still going 5 meters per second, over, and then we have our a, 0.5, and I apologize for any yelling you can hear in the background. My brother is playing video games, and he gets pretty loud. Okay, so you get a delta x of 57. So with that, we can just plug it into our delta x over here. And you get work equals 342, and joules is the unit. Okay. Part E, calculate the distance traveled between 8 and 10. Okay, so looking at our graph, we see that from, so from 8 to 10, we have a new force, 3. So we need to calculate that acceleration. Okay. And then with that, we need to find our VF at 10 again, so we can kind of repeating this process. Essentially, we're going to find our VF, and then we're going to use common form again. So AT plus VI, 0.75, and our T is 2, and our VI is going to be 14 because we found that the block is going 14 at 8 seconds. Okay, plug that into our calculator. Okay, and like I said, we're just kind of repeating this, so we're going to do common form again. Plug in what we've found. Okay. Okay, so it travels a distance of 29.5 meters between 8 and 10 seconds. So now part F wants us to graph position, velocity, acceleration versus time for the time 8 to 10. Okay, so let's do position first. Okay, so we know that when it comes to a position graph, okay, so we know for one thing, actually, let's do velocity because it might be easier to explain it. And then go backwards. Okay, so we know our velocity is increasing because we know there's no acceleration, and it's increasing linearly, constantly from 8 to 10 because there's a constant force. So yeah, because we found the velocity at 8 seconds was 14, and at 10 it's 15.5. That shows it's increasing, so it's gonna still, at 8 seconds it starts at a time, and by the time it gets to 10 seconds it's at another v. So it's going to be increasing constantly, but it also doesn't start at 0 because we're starting at intervals 8 and 10. We're starting at interval 8, and it already has a speed at 8, so it can't start at 0. So when it comes to our position, that's going to be exponential because our object, or the block, is increasing. Its speed is increasing more and more, so that means the distance it's traveling is going to increase every interval. And again, it doesn't start at 0. Okay, and then AT. Okay, and then AT, again, from 8 to 10, there's a constant force, which means there's going to be a constant A, and again, not at 0 because there is an acceleration. And that concludes FRQ 6.